In this video, I will be talking about the scan to BIM process. This is one of the largest shifts in the AC industry and demand is growing each year. Let's go. This presentation has been made with the help of Vishal and the team from Undead. This is a Revit plugin and software for optimizing the process of implementing point cloud data in Revit and avoiding all of the issues that are common with using point clouds in Revit. If you want to check them out, the link will be up in the cards above and then also down in the description of this video. In collaboration with Undead, we have created a whole course on this topic. It's 5 hours long and it takes you through all phases and tasks of Scan to BIM, showing and explaining each step on an actual project. If you would like to go get this course, it's available on balkanarchitect.com. Link is in the cards above and then also down in the description of this video. Now to the topic at hand. Scan to BIM is a process of scanning buildings, generating a point cloud from that scan, and then using the point cloud to model the building in a BIM software like Revit. Now let's start with explaining what is a point cloud. Point cloud is a large collection of data points in 3D space. Just imagine a 3D digital building, but instead of being solid geometry, is just a lot of individual points that hold data like their position in space as well as color. These points are captured using a 3D laser scanner or a LiDAR device. A laser scanner emits a laser and then measures the time it takes for that laser to bounce off a surface like a wall or a floor. This time of flight data is then converted into distances, resulting into a 3D scan. Now, apart from the 3D position, a laser scanner can record reflectivity as well as color or RGB values. Laser scanners are really accurate. They can capture data down to a few millimeters, and this is perfect for complex buildings such as heritage structures or irregular surfaces. These scanners can be mounted on flying objects like planes or drones. Alternatively, you can place them on a vehicle like a car, train, or trolley. And finally, we can just place them on a tripod and move them around from spot to spot by hand. For architecture, you will usually see drones being used for the exterior of the building and then terrestrial or just tripod-mounted scanners for the interior. Now, let's talk about converting point cloud scans to BIM. These scans are just a cloud of unstructured points. During the scan to BIM process, we are structuring them in an intelligent BIM model. We are basically telling Revit in this case that this set of points is a floor, and then this other set of points, well, that's a wall, and so on. These BIM models are created for a variety of reasons. It might be documentation for renovating, retrofitting, or heritage preservation. It can be clash detection and coordination for integration of new and old components. It can also be for facility management like operations, maintenance, and future modifications. Finally, it can be used for construction verification like discovering construction errors, deviations, and similar issues. When it comes to the end result, we have two types of scan to BIM projects: as-built models and look-like models. The main difference between these two can be derived from their names, that is, the level of detail and accuracy. Look-like models will simplify geometry to make it clear, whereas as-built will have more polygons and often look messier, but it will be much more accurate. This whole process of scan to BIM is powerful and efficient, but also has a lot of challenges. First, we have high-end hardware needs. Files are large and we need good graphics and a lot of RAM. Then we have noise and redundancy with things like shadows, random points kind of flying around the place, and bad quality data. Manual interpretation is next, with need of field knowledge, judgment calls, and identification issues. Scan to BIM does save a lot of time that would be spent measuring the building, but it still lacks automation in the process of converting point clouds to BIM models, as only 20 to 30% of the job can be automated. It also requires highly skilled professionals for the job. Finally, we have the issue of inconsistent standards like confusion in LOD, LOI, and LOA, where every client will have their own interpretation of LOD, and adaptability is needed to fulfill different kinds of requests. Hopefully, I've made this very complex topic of scan to BIM a bit clearer for you, and if you'd like to start learning about the whole scan to BIM process inside of Revit, you can find the full course in the cards above and down in the description of this video. And again, thank you to the Undead team for helping us out in creation of this course. Thank you for watching, guys. Make sure to check out my website, balkanarchitect.com, for more Revit courses. There I have over 120 hours of content, and I'm adding more each week. Make sure to subscribe for more videos, and also I've added a video over there that might interest you as well.